So there's a lot of home battery systems out on the market right now allowing you to store your solar energy, but I've noticed that there's a very big difference in terms of how they actually perform. Some units might have better internals than others, even though all of the marketing specifications seem to look very similar. Most of these units have 2.56 kilowatt hours of internal capacity, but when you actually put them side by side, there seems to be a big difference in how much you're actually able to pull out of the units. And in this video, we're checking out the CONOW Lyra 2500 AC units, doing some real-world in-depth testing on their round trip efficiency and how much you're actually able to get out of the units themselves to ascertain if these are worth your money or not. Now, this video was sponsored by CONOW, but they have no editorial input over what I say in the video, and I'm just sharing my test results and efficiency numbers that I was able to get out of these units. You can then take those numbers and see which one is best for your use cases. So personally, I haven't heard of CONOW before, but they apparently have about 15 years of experience in the home battery market. Alongside the home batteries, they're also building a broader home energy management ecosystem. And the idea here is that multiple home battery units can connect with your smart home devices and actually determine how much to push into the household or store on the battery units themselves. That said, for this video, we're going to be focusing on the battery units themselves and not too much on the whole ecosystem. Now, CONOW does have a different unit available. I have the AC versions here, but they also provide the Pro versions, and the Pro versions have MPPT inputs directly connected on the device. So you could allow your solar panels to be connected to the device directly and store the energy in that way. The nice thing about these particular units and all of the other units that are now hitting the market is, of course, their plug and play nature. So you have a simple power plug over here. You plug that into the wall, and the battery will provide power into the household via this power plug and also charge the battery via the power plug as well. Now, the first time I saw this, I thought this was very sketchy. I mean, what if you hit both poles over here, you get electrocuted or something? But they seem to have made this quite safe. Not entirely sure how. I think it's because of the grid syncing technology. So as soon as it senses the grid, then it turns on the battery. And when it doesn't sense the grid, it turns it off. That also makes it safe for the electricians working on the grid during a power outage. The packaging is relatively simple. You do get this little cover plate for the rear of the unit. And the units themselves are really sleek and minimal. They have this metallic housing. We have two AC plugs at the back with little flaps on there to keep the IP rating intact. And I do really appreciate that the flaps are connected to the unit themselves, so you don't actually lose these. We have a comms port. This is where you can connect an Ethernet cable onto the side of the unit and get a better connection to either your network, or you can connect multiple units together and get additional features via that comms port. And in the packaging, you also receive a power plug. This one is actually really decent in size. The power plug is quite a bit smaller than all of the other units that we tested in the past, and this one does stick out a little bit, so you can't flush mount this with the wall. Not sure if that's a bad thing, because the cooling system, of course, is at the rear of this device. So it is nice that there's a little bit of room between there. Once you plug the batteries into the wall, you can set them up via the application. And at the front of these units, you'll see these LED indicators, which are really quite useful. They indicate what the battery is actually doing at a given time. Now, a lot of these battery manufacturers don't put the real world battery capacity on screen, right? They have the claimed battery specification, which is 2.56 kilowatt hours. But how much are we actually able to get out of the device in real world use cases? That's the number that most people are looking for, because that also indicates the efficiency of it. There's energy being lost during the transfer, right? We need to calculate that. So to measure this, I charged the battery to 100% and then connected a load to it and then discharged it to 10%. That's the limit, so that it doesn't damage the cells. And then I measured how much it actually output via the power socket. I used the Shelly power plug to actually measure the entire situation. I don't have equipment that's more accurate than this device, but it should be within 3% variance. Now, by the time the battery hit its 10% limit, I had used 2.22 kilowatt hours of electricity. Now, because the battery still had 10% charge remaining, we can estimate the total system capacity, right? And that works out to roughly 2.47 kilowatt hours of usable electricity compared to the advertised 2.56 kilowatt hours. And that's actually a pretty decent result, suggesting that most of the battery's capacity is available for the user and there's not too much being lost in the transfer. But you have to keep in mind that that is an estimate based on the reported state of charge. And the more important takeaway here is that the battery delivered 2.2 kilowatt hours of usable AC electricity before reaching its 10% limit. The next step is to charge the battery back up to 100% and measure how much it actually needs from the wall. And this will allow us to calculate the round trip efficiency of the system. To recharge the system from 10% back to 100%, we consumed about 2.65 kilowatt hours from the grid. And earlier during the discharge test, we were able to get 2.2 kilowatt hours back through the AC output. So that gives us a measured AC to AC round trip efficiency of about 84%. In other words, for every 1 kilowatt hour I put into the battery, I get 0.84 kilowatt hours out of the battery. So the remaining energy is lost through the charging electronics and the battery system itself, and the inverter that is converting the stored energy back into AC power. Now 84% is not a spectacular result, but it's also not unusable, and it's quite common for battery systems like this. More importantly though, I was measuring this at the maximum charging speed, right? So 1500 watts. I did see it dip down to 1200 watts after a certain period of time. That might have had to do with thermal throttling in some regard. But in general, that's a pretty decent result. And if you would go for a lower charging rate, that would also increase the efficiency of the system a little bit. Now we'll head over to the peak load performance. I was actually quite surprised by the integration that we saw over here. So I run my washing machine on the battery unit itself. The washing machine consumes about 1800 watts. These units have a bidirectional inverter, which is 1500 watts, right? So realistically, you can only exceed that 1500 watts for a couple of seconds or minutes. In the case of that washing machine test, I was able to sustain that 1800 watts for about 3/4 of an hour. And that's actually because it's pulling 1500 watts from the batteries themselves, and then it's feeding through another 300 watts from the grid. So it's not actually pulling that 1800 watts from the battery, it's nicely splitting those up into two components, right? So when it's in its washing cycle and it's still consuming 1800 watts, I unplug it from the wall, it sustains that for a couple of seconds or minutes, and then it goes into the overcharge protection, starts flashing the LED and cuts off the power. Now if you're in a more off-grid scenario and you'd like to increase that, you can actually connect two units together by plugging the power socket of the other into the AC socket at the back over there, and then that way it increases the output capacity to 2400 watts instead of 1500 watts. One of the features that CONOW actually advertises is the 10 millisecond UPS backup mode. That means that when the grid connection goes down, all of the appliances connected to the back of the unit immediately receive power from the battery unit itself, right? And I tested this by connecting it to my computer. I started at Battlefield 6, so it's consuming about 700 watts. Unplugged it from the wall, and the game didn't see any interruptions. The computer stayed on, the monitor also stayed on. There was no flickering involved whatsoever. So I don't have any additional equipment to actually test if it's 10 milliseconds or not. One thing to note though is that UPS backup is only for the devices connected to the rear of this device, right? So when the grid connection goes down, it has anti-islanding tech built in, so it's not able to feed back into the household at that point. Moving on to the noise and the thermals, as far as I can tell, these units are passively cooled, and they don't have any fans in the inside. They have this gigantic heatsink at the back over there. I don't notice any electrical noise or anything like that, so they're essentially silent. The units do get quite warm when they're in a prolonged load, so when I charge these at 1500 watts for a couple of hours, it does get a little hot to the touch, but I've never had my hands burn on it or anything like that. I don't have a thermal camera to actually see where the heat is coming from, or if it's actually being distributed nicely. You have to check out a different video to actually ascertain that. So the software integration with these battery units is already quite developed. It's fully functional as far as I can tell. And I really like this feature where I can tap find device and it starts blinking the LED that's on the front of the unit. And that's interesting because that also somewhat ties into the way that CONOW is positioning these devices. So normally when you enter the battery market, you have the capability to stack the batteries to increase their capacity, right? These batteries don't stack, but you can increase the capacity by just buying multiple units. They have this interesting tech built in called AirMesh, which allows them to create their own wireless network and communicate with each other. So even if your Wi-Fi connection goes down, the AirMesh technology is still able to coordinate the whole system. The benefit of this, of course, is that you can place individual units scattered throughout the household, and then that way you can actually connect to the AC ports at the back of the units. So I could have my 3D printer connected to a battery unit, can have my computer connected to a battery unit, and they're still working together, but as soon as you have a power outage, then it uses the UPS connection to actually draw power from that unit, right? That said, for my specific integration where I'm integrating these into the washer dryer cabinet and solving the peak load problem in my space, these units are really quite capable and I've enjoyed them so far. They've been working out really quite nicely. Anyway, I hope this video was helpful and I hope you have a good day.